Have you ever rested your hand against a cold glass window on a quiet evening and wondered why it feels so completely solid? We move through the world, taking for granted the firmness of the ground beneath our feet, the comforting weight of a stone resting in our palm, the impenetrable barrier of a closed wooden door. This is a quiet paradox that hides in plain sight, a profound contradiction between what our daily human senses tell us and the ancient, fundamental truth of the cosmos. You might feel entirely still as you sit and listen to these words, perfectly at rest in a silent room, but beneath the threshold of your perception, a vast and restless ocean of invisible motion is unfolding in every direction. We are going to embark on a gentle journey into the deepest layers of reality today, peeling back the comforting illusion of the everyday world to reveal a mystery that has baffled the greatest minds in the history of human science. This journey requires us to leave behind everything we think we know about how solid matter behaves, and to embrace a universe that is far stranger and far more beautiful than our daily intuition could ever suggest. Welcome to Theodore, the researcher. I have noticed that 71% of the people who watch our videos and join us on these contemplative explorations have not subscribed yet. If you find peace and wonder in these quiet journeys through the cosmos, please consider subscribing to the channel. It helps us tremendously to continue bringing these deep mysteries to you, and it ensures we can keep wandering through the infinite wonders of the universe together. Now, let us return to that solid glass window, to the quiet room, and to the hidden reality resting just beneath your fingertips. When you touch a solid object, you're not actually touching it in the way you might imagine. The sensation of pressure, the feeling of texture, the unyielding resistance of the glass or the wood, all of this is a grand cosmic illusion, a sleight of hand performed by the fundamental forces of nature. To understand why this is, we must zoom in past the visible surface, past the cellular structure, down into the realm of the incredibly small, down to the atoms that make up everything you have ever seen, touched, or loved. For a very long time, humanity believed that atoms were tiny, indivisible, solid spheres like microscopic billiard balls stacking together to build the architecture of reality. But in the early 20th century, scientific pioneers began to peer closer, using ingenious experiments to probe the heart of matter. What they found shattered our understanding of the physical world. They discovered that the atom is almost entirely empty space. To give you a sense of this vast emptiness, imagine that the nucleus of an atom, the dense core where almost all of its mass is concentrated, is the size of a single small marble resting exactly in the center of a massive professional football stadium. The outer edge of that atom, the boundary that determines its size, would stretch all the way to the highest seats in the distant bleachers. And what occupies that enormous silent gulf between the marble-sized nucleus and the stadium walls? Almost nothing. A profound, echoing void. But navigating through that vast microscopic emptiness are the entities we are going to explore today. The electrons. They are the elusive, phantom-like dancers that give matter its structure, its chemistry, and its illusion of solidity. Carl Sagan once famously reminded us that we are made of star stuff, that the very atoms in our physical bodies were forged in the colossal, ancient furnaces of distant suns billions of years ago. But those atoms, that glorious star stuff, are built upon a foundation of absolute, profound strangeness. The electron is one of those foundational building blocks, what physicists call an elementary particle. This means that, as far as our most powerful instruments and our deepest theories can tell, the electron is not made of anything smaller. It has no internal structure, no gears, no microscopic components. It is a fundamental point of reality, an indivisible unit of the cosmos. Yet, describing it as a point or a tiny sphere is where our human language and our everyday intuition begin to fail us entirely. When we try to visualize an electron, we naturally picture a minuscule speck of matter orbiting the nucleus of the atom, much like the planets in our solar system orbit the sun. This planetary model of the atom is taught in schools around the world because it is comforting, easy to draw, and easy to understand. But the universe is under no obligation to be easy for us to understand. The truth about the electron is far more mysterious and requires us to embrace a reality that feels almost like magic. In the quantum realm, the rules of everyday physics simply dissolve. An electron does not orbit the nucleus in a neat, predictable circle. It does not travel along a clean trajectory like a train on a track or a moon around a planet. Instead, the electron exists in a state of continuous, restless probability. It is a smear of potential, a hazy cloud of likelihood that envelops the nucleus in complex, beautiful, three-dimensional patterns. We call these patterns orbitals, but they are not paths. They are regions of space where the electron might be found if we were to look for it. Until we actually interact with it, until we force the universe to reveal its hand, the electron does not possess a definite, single location. It is, in a very real and mathematically proven sense, everywhere within that cloud at once. This idea is staggering. It challenges our most basic perception of how objects behave. If you leave your keys on a table and walk out of the room, you know exactly where they are. They possess a defined location regardless of whether you're looking at them or not. But an electron does not behave like a set of keys. It exists in a superposition of possibilities, a shimmering ghost of a particle that refuses to be pinned down to a single reality until it absolutely must. This is not because our microscopes are too weak or our measurements are flawed. It is a fundamental feature of the fabric of the universe. The cosmos at its most basic level is built on uncertainty and probability, a quiet chaos that somehow, miraculously, gives rise to the predictable, stable world we experience every day. Consider for a moment the sheer scale of the numbers involved. A single drop of water, so small and insignificant that you might wipe it from your brow without a second thought, contains roughly 1.5 sextillion atoms. That is a 1 followed by 21 zeros. And within each of those atoms, electrons are engaged in their ceaseless, probabilistic dance. If you were to count the electrons in that single drop of water, one by one per second without ever stopping to sleep or eat, the universe would grow old and cold. Trillions of years would pass, and you would not even be close to finishing your count. When your hand touches the glass window, the atoms in your skin do not actually make physical contact with the atoms in the glass. The vast emptiness of your atoms meets the vast emptiness of the glass's atoms. What you actually feel, the sensation of solidity, is the invisible silent repulsion between the electron clouds in your hand and the electron clouds in the window. The electrons bearing a negative electrical charge push away from each other with incredible force. You are floating, perpetually hovering, a microscopic fraction of a millimeter above every surface you have ever touched, supported by an invisible cushion of quantum repulsion. You have never actually touched anything in your entire life. You have only ever felt the forceful, silent whisper of electrons pushing back against you. This revelation is an invitation to humility. We build our lives our cities, and our civilizations on the assumption of solid ground and tangible matter. Yet, the deepest science tells us that the foundation of our world is an elusive, vibrating mist of probabilities, governed by laws that defy common sense. The electron is a wanderer, a tiny spark of infinite mystery that races through the wires of your home, powers the device you are using to listen to this, and binds together the very molecules of your DNA. It is everywhere, indispensable, and ubiquitous, yet it completely escapes our ability to visualize it accurately. This brings a sense of intellectual safety, a reminder that it is perfectly acceptable, even necessary, to not know everything. We are finite beings trying to comprehend an infinite architecture. The electron teaches us that the closer we look at the universe, the more it demands we surrender our preconceived notions of how things should behave. It invites us to replace our desire for rigid certainty with a much more peaceful state of mind, a state of perpetual, gentle wonder. As we sit here in the quiet of this moment, billions upon trillions of these phantom particles are dancing within you, maintaining the structure of your being, allowing your heart to beat and your neurons to fire, enabling the very thoughts and wonder you're experiencing right now. The universe is not just vast and mysterious out there in the distant reaches of space, in the swirling galaxies and the ancient light of dying stars. It is vast and mysterious right here, in the spaces between your fingers, in the silent depths of your own body. We will continue to venture deeper into this strange, microscopic landscape, to understand how these particles communicate, how they can spin without actually spinning, and how they can be completely entangled with one another across impossible distances. We will peel back more layers of this beautiful illusion we call reality. But for now, just let yourself rest in this new understanding. Let the profound strangeness of the quantum world wash over you, not as something to fear or to solve, but as a masterpiece to be admired. The universe has constructed an infinitely complex, beautifully stable reality out of emptiness and probability. It is a masterpiece painted with invisible brushes, and you are both the canvas and the observer. As you breathe in the quiet air around you, remember that you are breathing in mysteries, inhaling countless invisible wonders that operate in perfect harmony to give you this fleeting, beautiful moment of existence. In the next step of our journey, we will explore one of the most counterintuitive aspects of this tiny wanderer. We will discover how an electron spins without truly spinning, a paradox that sounds impossible to our human logic, but forms the very basis of magnetism and the technological world we inhabit today. There is no need to rush to understand it all at once. The cosmos has waited billions of years for us to ask these questions, and it will wait as long as we need to find the answers. For tonight, simply let your mind float in the vast, quiet spaces between the atoms, suspended in the gentle tension of knowing that the reality you touch is not quite what it seems, yet it holds you safely all the same. Imagine, for a moment, a simple child's toy, a wooden top spinning gracefully on the surface of a polished table. As you watch it turn, you see the blur of its motion, the way it perfectly stabilizes itself against the relentless pull of gravity, fighting the urge to fall simply by virtue of its continuous rhythmic rotation. This is a comforting, familiar image. We understand the concept of spinning intuitively. We feel the earth slowly turning beneath us, completing its vast, silent rotation every 24 hours, gifting us the gentle transition from the bright warmth of day to the quiet, star-filled mystery of the night. Rotation is everywhere, in the macrocosmic world we inhabit. Planets spin on their ancient axes, stars spin in their glowing stellar nurseries, and entire galaxies cartwheel through the infinite void in a majestic, slow-motion ballet that has been ongoing for billions of years. It is only natural, then, that when scientists first discovered the electron, they pictured it doing exactly the same thing. They imagined a minuscule, electrically charged sphere pirouetting in the dark, empty space of the atom. It is a beautiful, intuitive picture, one that our human minds can easily grasp and hold on to. But the universe, in its infinite creativity, is not bound by the limitations of our everyday intuition. As we prepare to step beyond the boundary of classical physics and into a realm where the impossible becomes the fundamental rule of existence, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who join us on these quiet, contemplative journeys through the deepest mysteries of the cosmos, have not subscribed yet. If you find peace, wonder, and a sense of intellectual safety in these explorations, please consider subscribing to the channel. It helps us tremendously, allowing us to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite wonders of the universe, together, side by side, as a community of curious explorers. Now, let us return to our tiny, invisible dancer, the electron, and the paradox that broke the minds of the greatest physicists of the 20th century. When pioneers of quantum mechanics began to study the behavior of the electron in magnetic fields, they realized that the particle was behaving exactly as if it were a tiny, spinning magnet. It possessed what physicists call angular momentum, the mathematical property that describes rotation. It seemed at first glance that the planetary model was correct. The electron was simply a tiny, spinning ball of negative charge. But a profound problem soon emerged, a contradiction so deep that it threatened to unravel the entire framework of physics. To understand this paradox, we must remember what we discussed in our last journey. The electron, as far as our most powerful particle accelerators and deepest mathematical theories can reveal, is an elementary particle. It is a fundamental point of reality. It has a mass. It has an electrical charge, but it does not possess any physical volume. It has no radius, no width, no height, no depth. It is a dimensionless speck of existence. How, then, can a dimensionless point rotate? For something to spin, it must have a center, and it must have an outer edge that travels around that center. If an object has no size, there is no edge to move, no distance to travel, no geometry to rotate. The very concept of spinning requires space, yet the electron occupies no measurable space at all. This was the first gentle whisper from the cosmos that our human language and our macroscopic analogies were completely failing us. But the physicists of the early 20th century were stubborn, driven by a profound existential curiosity. They asked themselves a hypothetical question. What if we are wrong? What if the electron does have a tiny, hidden radius, a volume so incredibly small that our instruments simply cannot measure it yet? What if it actually is a tiny physical sphere spinning in the dark? When they calculated the mathematics required for this hypothetical sphere to generate the specific magnetic field that the electron is known to produce, the result was staggering. For a sphere of that unimaginably small size to spin fast enough to create the electron's magnetic field, the outer equator of that sphere would have to be traveling significantly faster than the speed of light. According to Albert Einstein's theory of relativity, the speed of light is the absolute, unbreakable speed limit of the universe. Nothing that possesses mass can ever reach it, let alone exceed it. If the electron were a physical object physically spinning, it would violate the most fundamental laws of the cosmos. It would break the fabric of reality itself. And so, the scientific community was forced to surrender their comforting, intuitive picture of the world. They had to embrace a profound, quiet mystery. The electron does not spin, not really, not in any physical, spatial sense that we can visualize or comprehend. Yet, it possesses the exact mathematical properties of spinning. It has angular momentum. It generates a magnetic field. It interacts with other particles as if it were rotating. Physicists, searching for words to describe the indescribable, called this property intrinsic spin. It is a fundamental characteristic of the particle, woven into its very existence, just like its mass or its negative charge. You cannot stop an electron from spinning, and you cannot speed it up. It simply possesses a state of spinningness without the physical act of motion. It is a ghost of a movement, a mathematical reality that casts a physical shadow into our world. This might sound like an abstract mathematical trick, a quirk of equations written on a dusty chalkboard. But this ghostly, non-physical spin is the reason the physical world behaves the way it does. It is the reason you can experience the world around you. Let us bring this vast, invisible mystery back to your everyday life. Think of a simple magnet holding a photograph to the door of your refrigerator. That invisible force, that silent, persistent pull that defies the gravity trying to pull the photograph to the floor, where does it come from? It does not come from the metal itself. It comes from the quantum spin of the electrons hidden deep within the atoms of that metal. In most materials, the electrons are arranged in pairs, with their quantum spins pointing in opposite directions, perfectly canceling each other out, leaving the material magnetically silent. But in a piece of iron, the architecture of the atoms allows some of these electrons to remain unpaired. When the invisible, non-physical spins of trillions upon trillions of these unpaired electrons align, all pointing in the same quantum direction, their tiny, ghostly magnetic fields combine. They add up, accumulating into a massive, macroscopic force that reaches out across the empty space and grips the metal of your refrigerator door. That familiar, everyday phenomenon is nothing less than the amplified whisper of the quantum world. You are holding in your hand the macroscopic evidence of a paradox, the tangible proof that the universe is built upon entities that spin without spinning. There is a profound meditative peace to be found in this realization. We spend much of our lives trying to force the chaotic, unpredictable events of our daily existence into neat, understandable boxes. We want things to be purely logical. But the electron, resting quietly at the foundation of all matter, teaches us a lesson in profound humility. It gently reminds us that the cosmos is under no obligation to be immediately understandable to the human mind. The universe does not owe us a reality that perfectly matches our intuition. It is vast, ancient, and operates on rules that are breathtaking in their alien beauty. When we let go of our need for absolute comprehension, we find a deep sense of intellectual safety. The electron's impossible spin is a beautiful, eternal paradox to be contemplated. It invites us to sit quietly with the mystery, supported by these phantom particles dancing in the microscopic dark. But the strangeness of the electron does not end here. In our next chapter, we will explore spooky action at a distance, discovering how two electrons can become so intimately entangled that a change in one instantly affects the other across the vast, silent gulfs of the universe. For now, simply allow yourself to rest in the quiet present, anchored by the invisible spin of a trillion electrons, holding you safely in the gentle embrace of the physical world. Have you ever stood on the shore of a vast, dark ocean, listening to the gentle rhythm of the waves crashing against the sand, and felt a profound, almost aching sense of distance from the horizon? In our everyday human experience, space is an absolute barrier. If you are here, you cannot be there. If you wish to affect something on the other side of the room, you must cross the quiet emptiness between you, or throw an object, or send a sound wave rippling through the air. Separation is the fundamental rule of our macrocosmic reality. We are isolated entities, bound by the limits of our physical bodies, separated by the vast, stretching miles of the earth and the infinite, freezing vacuum of the cosmos. But what if I told you that this deeply ingrained intuition, this feeling of absolute separation, is yet another magnificent illusion? What if the universe, at its most fundamental, hidden level, does not care about distance at all? Today, we are going to dive deeper into the mysterious life of the electron, peeling back the illusion of space to uncover a phenomenon so deeply unsettling and profoundly beautiful that it challenged the greatest scientific mind of the 20th century. We are going to explore a secret connection that binds the building blocks of reality together, a quiet whisper across the infinite dark that defies everything we thought we knew about how the universe operates. Welcome back to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos and join us on these gentle, contemplative journeys into the unknown have not subscribed yet. If you find comfort, wonder, and a sense of peaceful curiosity in these quiet explorations of the cosmos, please consider subscribing to the channel. It helps us tremendously to keep creating these meditative voyages, allowing us to continue unraveling the deepest mysteries of the ancient universe together as a community of seekers. Now, let us return to that feeling of distance, to the dark ocean, and to the invisible, impossible threads that connect the fundamental particles of our world. To understand this impossible connection, we must return to our tiny, ghostly wanderer, the electron. As we discovered in our previous journeys, the electron is not a solid sphere, but a shimmering cloud of probabilities, a particle that possesses a mathematical spin without physically spinning. But the strangeness of the quantum realm multiplies exponentially when two of these elementary particles interact. Imagine two electrons born at the exact same moment from a single energetic cosmic event, perhaps in the fiery, chaotic heart of a dying star, or in the pristine, highly controlled environment of a modern physics laboratory. Because they share this singular origin, their quantum states become inextricably linked. They form a single, unified mathematical description, a shared existence that supersedes their individual identities. Physicists call this profound relationship quantum entanglement. When two electrons are entangled, they cease to be two entirely separate entities and instead become a single, extended system, no matter how much physical space lies between them. To picture this, imagine a pair of magical dice. If you roll one die in your quiet living room and it lands on a 6, the other die, even if it were resting on the dusty, cratered surface of the moon, would instantly and simultaneously reveal a matching 6. There is no hidden mechanism connecting them, no invisible radio signal crossing the vast, silent void of space. The connection is intrinsic, immediate, and utterly flawless. If you measure the ghostly, non-physical spin of one entangled electron and find it pointing up. You instantaneously know with absolute mathematical certainty that the spin of its entangled partner is pointing down. This instantaneous correlation troubled Albert Einstein deeply. He referred to it, with a mixture of skepticism and awe, as spooky action at a distance. For Einstein, the universe was governed by a strict, unbreakable speed limit, the speed of light. Nothing, not a particle, not a wave, not even a single bit of information, should be able to travel faster than the light from a distant star. If one electron is measured on Earth, and its partner is measured on a hypothetical spacecraft orbiting the distant rings of Saturn, how could the second electron instantly know what happened to the first? For a signal to travel between them, it would take hours, yet the entanglement responds in zero time. It is immediate. It bypasses the intervening space entirely, as if the space itself were merely an illusion, a convenient fiction painted over a deeper, more unified reality. In the decades since Einstein first pondered this mystery, scientists have rigorously tested this spooky action, pushing the boundaries of human engineering to confirm the impossible. Researchers have entangled particles and separated them by tens of kilometers across silent, sleeping cities. They have beamed entangled particles from the surface of the Earth to satellites orbiting high above the atmosphere, separating them by hundreds and even thousands of kilometers. Every single time, the universe has responded with the exact same mind-bending truth. The connection remains instantaneous. The distance simply does not matter. The electrons act as a single, indivisible whole, completely ignoring the vast, cold gulfs of the cosmos that sit between them. Let us pause for a moment to let the sheer weight of this reality settle into our minds. We live in a universe where things can be separated by oceans, by continents, by the impossible emptiness of interstellar space, and yet remain intimately, perfectly connected. The electron, this tiny, invisible point of mass and charge, teaches us that the cosmos is not a collection of isolated, lonely objects drifting aimlessly through the dark. Instead, it is a deeply woven tapestry, a singular, continuous fabric of existence, where the boundaries we perceive are merely the limitations of our human senses. When you look up at the night sky, you are not merely observing a distant, disconnected scattering of ancient fires. You are looking at a universe that is, at its most fundamental quantum level, humming with hidden connections, bound together by invisible threads of probability and entanglement. This realization invites a profound, comforting humility. We often feel small and isolated when we contemplate the infinite vastness of the cosmos, when we think about the billions of years that have passed before we were born, and the billions that will continue long after we are gone. But quantum entanglement offers a different perspective, a gentle reminder that isolation is an illusion. The very particles that make up your body, the electrons dancing in the carbon of your cells and the iron of your blood, were forged in the primordial fires of the early universe. It is entirely possible, mathematically speaking, that electrons within you are currently entangled with electrons resting in the silent dust of a distant, unseen galaxy. You are quite literally, physically, and quantum mechanically woven into the fabric of the cosmos. This is the true beauty of scientific inquiry. It does not strip the universe of its magic. Rather, it reveals a magic far more profound and intricate than any human myth or legend could ever invent. It replaces our simple, comforting assumptions with breathtaking, awe-inspiring mysteries that invite us to keep exploring, to keep asking questions, to keep wandering through the dark with open minds and curious hearts. The electron, in all its strange, non-physical spinning and its impossible, instantaneous connections, is a testament to the infinite creativity of the universe. It shows us that reality is not a rigid, mechanical clockwork, but a vibrant, mysterious, interconnected dance of probabilities. As we sit in the quiet stillness of this moment, enveloped by the peaceful silence of the present, let us embrace the tension between what we can see and what science tells us is true. You do not need to fully comprehend the intricate mathematics of quantum mechanics to appreciate the wonder it reveals. You only need to be willing to look past the surface of things, to accept that the solid, separate world you interact with every day is built upon a foundation of profound, interconnected mystery. The universe is a single, breathing entity, and you are an inseparable part of its ancient, ongoing journey. In our next chapter, we will continue to follow the elusive electron as it reveals yet another impossible contradiction. We will explore how this fundamental particle can behave both as a solid, localized point of matter and as a spreading, non-local wave of energy, blurring the very line between what is a thing and what is an event. But, for now, let the concept of this spooky, beautiful connection bring you a sense of deep, contemplative peace. There is no distance too great, no void too vast to sever the fundamental threads that bind the universe together. Rest in the knowledge that you are surrounded by and composed of these impossible dancing particles, holding you securely in the gentle, infinite embrace of the cosmos. Have you ever sat quietly by the edge of a perfectly still pond, holding a small, smooth pebble in your hand, and watched the water? When you release the stone, it breaks the surface with a gentle plop, a single, defined object occupying a specific place at a specific moment in time. But as it sinks into the dark depths, it creates something entirely different. It creates a ripple, a spreading, continuous ring of energy moving outward in all directions, traveling across the quiet surface of the pond, touching the distant reeds and the muddy shores. In our everyday experience, these two concepts are completely distinct. There are things solid and localized, like the pebble you held in your hand, and there are waves, spreading, continuous events that transfer energy without transferring matter, like the ripples on the water or the sound of the wind moving through the ancient trees. We categorize the world neatly into these two boxes, confident in our ability to separate the solid from the ethereal, the localized from the spreading. But what if the deepest foundations of reality refuse to be placed into either of these boxes? What if the universe, in its infinite creativity, has woven together the nature of the solid stone and the spreading ripple into a single, incomprehensible entity? Today, we are going to continue our journey into the strange, beautiful life of the electron, peeling back another layer of the cosmic illusion to discover a paradox that defies all human logic. We are going to explore the moment when a localized particle dissolves into a spreading wave of probability, and how the very act of our observation forces the universe to choose a reality. Before we delve deeper into this mind-bending phenomenon and watch the boundaries of reality blur before our eyes, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who join us on this quiet, meditative journey through the mysteries of the cosmos have not subscribed yet. If you find comfort, peace, and a sense of intellectual safety in these explorations, please consider subscribing to the channel. It helps us tremendously, allowing us to continue crafting these gentle voyages into the unknown and it ensures that we can keep wandering through the vast, infinite wonders of the universe together as a community of curious minds. Now, let us return to our silent pond, to the falling pebble, and to the tiny, invisible wanderer that acts like both the stone and the ripple at the exact same time. To understand this profound contradiction, we must look at an experiment that the legendary physicist Richard Feynman once called the absolute heart of quantum mechanics, a phenomenon that contains the only mystery of the quantum world. Imagine a solid barrier with two narrow vertical slits cut into it, standing in the middle of a quiet, darkened room. Behind this barrier is a sensitive screen that records exactly where it is struck. If you were to take a microscopic cannon and fire tiny solid particles, like grains of sand or miniature marbles, at this barrier, the result would be entirely predictable. The particles that pass through the two slits would strike the screen behind them in two distinct vertical bands, perfectly matching the shape of the slits. This makes perfect, logical sense. Now, imagine replacing the cannon with a light source, shining a wave of light toward the same two slits. The wave passes through both slits simultaneously, breaking into two new, overlapping waves on the other side. As these two ripples crash into each other, they create what physicists call an interference pattern, a complex series of many alternating light and dark bands on the back screen. The light bands are where the crests of the two waves perfectly align and amplify each other, and the dark bands are where a crest meets a trough, quietly canceling each other out in a perfect mathematical silence. This is the classical, understood behavior of waves, just like the overlapping ripples in our peaceful pond. But the cosmos had a breathtaking surprise waiting for us when scientists decided to fire electrons, those fundamental, indivisible particles of matter, at the two slits. If the electron is a tiny, solid point of reality, as our intuition so desperately wants to believe, it should travel through one slit or the other, creating two distinct bands on the screen, just like the miniature marbles. But when the scientists turned on their instruments and fired a beam of electrons through the barrier, the screen slowly illuminated with a completely different reality. Instead of two simple lines, the electrons built up an undeniable, complex interference pattern of multiple alternating bands. They behaved exactly like the spreading wave of light. This was a shocking revelation. It meant that these elementary particles of matter, the very foundation of the solid objects you touch and hold every day, were moving through space not as tiny bullets, but as ethereal, overlapping waves. The electron was behaving as a smeared, continuous ripple of energy, passing through both slits at the exact same time, interfering with itself before eventually striking the screen as a single, localized point. It was a moment of profound scientific awe, a realization that the universe operates on a level of magical strangeness that human beings were completely unprepared to encounter. The scientists, driven by an insatiable existential curiosity, decided to push the experiment further, trying to outsmart the universe. They thought that perhaps the electrons in the beam were somehow bumping into each other, interacting in the dark, to create the wave-like pattern through some microscopic, unseen collision. So, they adjusted their highly sensitive equipment to fire the electrons one by one, with long, quiet pauses in between each shot. They fired a single electron, watched it strike the screen as a single, tiny, localized dot, and then fired another. Dot by dot, over hours of patient, silent observation, the screen slowly filled in the quiet laboratory, and as the dots accumulated over time, the impossible happened once again. They did not form two simple, logical bands. Dot by tiny dot, the single isolated electrons gradually painted the exact same multiple-banded interference pattern of a wave. This result is utterly staggering. It means that a single, solitary electron, traveling completely alone through the quiet void of the experimental chamber, somehow passes through both slits simultaneously, interferes with its own ghostly presence, and then decides where to land, based on the mathematical probabilities of a wave. It is as if the particle exists in a state of pure, undefined potential, exploring every possible path through the universe at once, a shimmering cloud of what-ifs and possibilities, only snapping into a definite physical reality at the exact moment it finally strikes the measuring screen. But the deepest, most unnerving mystery was yet to come. The scientists, desperate to understand how a single particle could possibly pass through two slits at the exact same time, placed a tiny, highly advanced detector right next to the slits to silently observe the electrons as they went through. They simply wanted to peek behind the cosmic curtain, to know for certain which path the electron actually chose to take. The detector was entirely passive. It did not disturb the electrons, it only watched them. But the universe, it seems, is fiercely protective of its deepest, most ancient secrets. The very instant the scientists turned on the detector to watch the electrons changed their behavior entirely. They stopped acting like a spreading wave of potential. The complex, beautiful interference pattern on the distant screen completely vanished into nothingness. Instead, the electrons suddenly began behaving exactly like solid little marbles, passing through either the left slit or the right slit, forming two simple, distinct bands on the screen. The mere act of looking, the simple insertion of conscious observation or measurement into the physical system, collapsed the electron's wave of probabilities. It forced the universe to abandon its state of infinite potential and choose a single, definite reality. This phenomenon, known globally as the observer effect, stands as one of the most profound and mysterious discoveries in the entire recorded history of human science. It suggests that reality, at its most fundamental, quantum level, is not fixed or absolute when no one is looking. It is deeply, inextricably entangled with the act of observation itself. The electron is not simply a particle, nor is it simply a wave. It is a breathtaking, ancient entity that entirely transcends these simple human categories of thought. It exists in a vast, silent realm of pure probability, a shadowy, unseen world of infinite paths and ghostly potentials, only taking on the concrete form we recognize when it is forced to interact with the macroscopic world. This revelation asks us to embrace a profound, quiet humility, to accept without fear that the cosmos is far more fluid, mysterious, and responsive than we ever dared to imagine in our wildest dreams. As you sit here, breathing quietly in the gentle stillness of this moment, remember that the atoms composing your physical form are built upon this very foundation of shimmering, undecided potential. You are composed of waves of probability that have miraculously collapsed into the beautiful, structured reality of your current physical existence. In our next journey, we will venture even deeper into the quantum fog, exploring the incredible principle that prevents these ghostly particles from crashing into each other, the invisible, silent rule that stops the entire universe from collapsing into a single, infinitely dense point of matter. But for now, just let yourself rest in the peaceful, beautiful uncertainty of the wave-particle duality. Let go of the desperate need for strict definitions and solid boundaries. You are a localized event in an infinite, spreading cosmos, a beautiful intersection of matter and wave, participating in a quiet, eternal dance with the universe itself. Rest in the comforting silence of the unknown, guided by the gentle mystery of the invisible world that surrounds you. Have you ever paused to look at the majesty of a mountain? Or perhaps just the sturdy wooden table in your dining room, and wondered what is truly holding it up? We are taught that gravity is the great sculptor of the universe, an ancient force that pulls everything together, seeking to crush matter into the smallest possible space. It is the invisible hand that gathers the cosmic dust to ignite the stars. Yet, despite this constant inward pulling over billions of years, the world around us has not collapsed. You are sitting on a chair, supported by the floor, resting on the crust of a planet, and none of this is falling through itself into a microscopic point of infinite density. Why? What is the invisible shield that stands against the crushing weight of the cosmos? Today, as we continue our quiet journey into the hidden life of the electron, we are going to explore the silent, unyielding rule that gives the universe its structure, its volume, and its variety. It is a principle of ultimate cosmic individuality, a mathematical law that dictates that no two electrons can ever truly be the same. This is the secret of solidity, the reason you occupy space in the world, and the foundation of all chemistry and life. Welcome back to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, those who share these quiet moments of reflection with us, have not subscribed yet. If you find value in these gentle explorations of the vast unknown, if they bring you a sense of peace and wonder, please consider subscribing to the channel. It helps us tremendously to continue crafting these voyages into the deep mysteries of existence, and it ensures we can keep exploring the infinite universe together as a community of curious minds. Now, let us return to the mystery of solid matter, to the silent battle against gravity, and to the strict, beautiful rules that govern the invisible world of the electron. To understand why the universe has volume, why things take up physical space, we must first look at the social behavior of the fundamental particles. In the grand tapestry of the cosmos, all elementary particles are divided into two distinct families. One family is called bosons. These are the particles that carry the fundamental forces of nature, like the photon, which carries the light from the ancient stars to your eyes. Bosons are deeply communal. They do not mind sharing the exact same quantum state. If you lower their temperature and bring them together, billions of bosons can seamlessly merge into a single unified entity, occupying the exact same microscopic point in space, singing in perfect, overlapping harmony. If the universe were made entirely of bosons, there would be no structure, no solid ground, no volume. Everything would simply collapse into a single, dimensionless point of blinding energy. But the electron belongs to the other great family of particles, a group known as Fermions. Named after the brilliant physicist Enrico Fermi, Fermions are the building blocks of matter. They are the protons, the neutrons, and, of course, our ghostly, dancing electrons. Unlike the communal bosons, Fermions are fiercely individualistic. They are governed by a mathematical law discovered by the Austrian physicist Wolfgang Pauli in the early 20th century. This law is known as the Pauli exclusion principle. The principle states, with unwavering mathematical certainty, that no two electrons in the exact same system can ever occupy the exact same quantum state at the exact same time. They demand their own unique, personal identity within the architecture of the atom. Imagine the atom not as a simple solar system, but as an ancient skyscraper reaching up into the dark. Each floor of this skyscraper represents a different energy level, and each floor is divided into specific rooms, which physicists call orbitals. The lowest floor is closest to the nucleus, where the pull of the positive charge is the strongest, like the comforting warmth of a fireplace on a cold, quiet winter night. Naturally, every electron in the universe wants to be on that bottom floor, resting in the lowest possible energy state. If electrons were like light particles, they would all crowd into that single bottom room, millions of them overlapping in the dark. But because of the Pauli exclusion principle, that bottom room has a strict capacity limit. It can only hold exactly 2 electrons, and even then, those 2 electrons must be completely distinguishable from one another. They achieve this through the ghostly property we discussed in our last journey, their intrinsic spin. One electron must spin in the upward direction, and the other must spin in the downward direction. Once those 2 microscopic slots are filled, the room is permanently locked. The universe puts up a silent barrier. When a third electron arrives, drawn by the pull of the nucleus, it finds it fully occupied. The fundamental laws of the cosmos forbid it from entering, and so it has no choice but to move up to the second floor, taking up residence in a new room, occupying a new, slightly larger volume of space. As we look at heavier elements in the universe, atoms with dozens of electrons swarming around their dense cores, we see this process repeating itself over and over. The electrons are forced to stack outward, filling higher energy levels, building a complex 3-dimensional cloud of probabilities that grows larger and larger. This outward stacking, this absolute refusal of the electrons to share the exact same state, is what gives atoms their physical size. It is the reason matter takes up space. The solidity of the wood, the firmness of the rock, the delicate structure of your own hands. All of it is the result of trillions upon trillions of electrons fiercely defending their individual quantum states, pushing against each other in the dark, maintaining the volume of the physical world. The profound beauty of this principle extends far beyond the simple concept of size. The Pauli exclusion principle is the singular reason why the universe is capable of generating complexity, chemistry, and eventually conscious life. Because the electrons are forced into these tiered arrangements, the outermost electrons of an atom are left feeling a little unstable, a little lonely. They reach out into the void, seeking to interact, to share their space, to bond with the outer electrons of neighboring atoms. This desperate, beautiful search for stability is what we call chemistry. Every chemical reaction that has ever occurred, from the slow rusting of ancient iron to the folding of the proteins in your brain, is dictated by the arrangement of these outer electrons. If the Pauli exclusion principle did not exist, chemistry would be impossible. The universe would be a barren, uniform wasteland of tiny, identical, infinitely dense points of matter. There would be no water, no air, no planets, and no one here to wonder about the silence. This silent, invisible rule of exclusion is so unimaginably powerful that its effects are not limited to the microscopic realm of atoms. It governs the fate of entire stellar systems. Let us take our minds far away from the earth, deep into the vast depths of the cosmos, to look at a dying star. When a star roughly the size of our sun finally exhausts the nuclear fuel in its core after billions of years of brilliant fusion, the outward pressure of radiation suddenly ceases. The star begins to die. The relentless, crushing grip of gravity finally takes over. The immense mass of the star begins to collapse inward, falling toward its own center with terrifying force. The matter is squeezed so tightly that the atoms themselves shatter, creating a dense, chaotic soup of atomic nuclei and a swirling ocean of electrons. Gravity wants to compress this dead star into a single, infinitesimal point. But as the star shrinks, the electrons are squeezed closer and closer together, forced into a smaller and smaller volume of space. According to the Pauli exclusion principle, they cannot occupy the same quantum state. As the space decreases, the electrons are forced to occupy higher energy states simply to avoid violating this fundamental law. They begin to move at tremendous speeds, pushing back against the crushing weight of the star with an almost incomprehensible force. Physicists call this phenomenon electron degeneracy pressure. It is a purely quantum mechanical pressure born from the electron's absolute refusal to be identical. And amazingly, the electrons win. This silent quantum rule is strong enough to halt the collapse of an entire star. The remnant becomes what we call a white dwarf, a glowing, cooling ember of degenerate matter, holding the mass of an entire sun within a sphere no larger than the Earth. It is an object of staggering density, but it does not collapse into a black hole, because the electrons, those tiny wanderers with no physical volume of their own, stand shoulder to shoulder in the dark, holding up the weight of a dead sun. This is the sheer, breathtaking majesty of the universe. The very same principle that prevents your hand from passing through the solid glass window is the exact same principle that holds up the ancient, glowing corpses of dead stars across the vast, infinite stretches of the cosmos. As we gently absorb the immense scale of this reality, we can find a deep sense of peace in the structure of the world. We are often overwhelmed by the chaos of our daily lives, but beneath that surface layer of human experience, the universe is governed by laws of profound stability and absolute individuality. You are a highly organized, beautifully complex collection of star stuff, held together by the gentle, invisible tension of billions of tiny particles that refuse to lose their unique identity. The cosmos is not a random soup of energy. It is a structured, magnificent architecture built on rules of exclusion and balance. In our next chapter, we will continue our journey with the electron, exploring another incredible paradox of its existence. We will venture into the realm of quantum tunneling, a phenomenon where this ghostly particle completely ignores solid barriers, passing through impenetrable walls of energy as if they simply did not exist. We will see how this impossible magic trick is the very reason the stars shine in the night sky. But for now, as the quietness of the present moment settles around you, let yourself appreciate the solid ground beneath your feet. Appreciate the firmness of the world. It is not an accident. It is a masterpiece of quantum resistance, a billion-year-old dance of particles that insist on holding their space in the vast, ancient dark. Rest in the knowledge that you, too, are supported by this incredible, invisible foundation, held safely in the gentle, structured embrace of the universe. Have you ever walked down a familiar hallway in the dark and accidentally bumped into a closed door? The experience is abrupt, immediate, and undeniable. A physical barrier seems absolute. If you throw a solid rubber ball at a thick brick wall, the ball will bounce back. It will never, under any normal circumstances, simply pass through the solid stone and appear on the other side. This is the bedrock of our classical understanding of physics. Energy requires sufficient force to overcome obstacles. If you do not have enough energy to climb over a mountain, you must stay in the valley. The universe, to our everyday senses, respects boundaries. Walls are walls, doors are doors, and the physical limits of our bodies keep us safely contained within the familiar geometry of our lives. But, as we have already discovered on this quiet journey into the microscopic dark, the universe is not bound by the comforting rules of our everyday intuition. At the fundamental level of reality, the boundaries that seem so solid and permanent begin to simply vanish. Today, we are going to explore a phenomenon so completely magical, so deeply counterintuitive, that it sounds like the plot of a science fiction story. We are going to watch the electron perform its greatest trick. We are going to learn how it walks through walls. Before we step through this invisible doorway and leave the classical world entirely behind, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who share these quiet, contemplative journeys through the deepest mysteries of the cosmos with us, have not subscribed yet. If you find peace, wonder, and a sense of intellectual safety in these gentle explorations, please consider subscribing to the channel. It helps us tremendously to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite wonders of the ancient universe together, side by side, as a community of curious explorers. Now, let us return to the impenetrable wall, to the limits of the physical world, and to the tiny, invisible wanderer that refuses to be contained by any barrier. To understand how an electron can pass through a solid barrier, we must return to the shifting nature of the particle. Remember the silent pond and the spreading ripples from our earlier reflections. The electron, as we have seen, is not merely a tiny, solid sphere of matter. It exists as a wave of probability, a smeared-out cloud of potential that mathematically describes exactly where the particle is likely to be found. When an electron traveling through a copper wire or moving through the empty space of an atom encounters a barrier, perhaps a layer of insulating material or a powerful magnetic field, it does not strike the barrier and bounce off like our classical rubber ball hitting a brick wall. Instead, the wave of probability crashes against the barrier. Now, classical physics strongly dictates that if the electron does not possess enough energy to climb over this barrier, it must be reflected completely. It is supposedly trapped, but the mathematics of quantum mechanics, formulated by brilliant minds who dared to trust the equations over their own common sense, reveal a startling truth. When the electron's probability wave hits the wall, it does not abruptly drop to zero. It does not simply cease to exist inside the barrier. Instead, the wave fades, but a tiny, ghostly fraction of that wave bleeds completely through the solid obstacle and emerges on the other side. Because the electron is a creature of pure probability, wherever its wave exists, there is a mathematical chance that the electron itself will suddenly be found there. If even a microscopic fraction of the wave manages to reach the other side of the impenetrable wall, it means there is a non-zero probability that the electron will simply appear on the other side, without ever having actually traveled through the physical space in between. It is as if you threw your rubber ball at the wall, and instead of bouncing back, the ball instantly vanished and materialized in the garden on the opposite side, perfectly intact. Physicists call this breathtaking phenomenon quantum tunneling. The electron does not drill a physical hole. It does not break the wall down into smaller pieces. It simply borrows a tiny amount of energy from the deep, silent uncertainty of the universe for a fraction of a millisecond, passes through the impossible barrier like a phantom, and gives the energy back on the other side. It tunnels through the very fabric of reality itself. This might sound like an incredibly rare, obscure mathematical quirk, an anomaly that only happens in the cold, sterile vacuum of highly advanced physics laboratories. But the truth is infinitely more profound and magnificent. Quantum tunneling is not a rare mistake in the code of the cosmos. It is the very engine of existence. To understand the staggering scale of this invisible magic, we must look up from our quiet earthly lives and gaze into the vast ancient sky. Think of the sun, that glorious burning sphere of plasma that has bathed our planet in warm, golden light for 4.5 billion years. The sun generates its immense energy through a process called nuclear fusion, where the crushing gravity of the star forces hydrogen nuclei, protons, to smash together and fuse into heavier elements. But here is the magnificent cosmic secret. The core of the sun, as unimaginably hot and dense as it truly is actually not hot enough or dense enough to force these protons together according to the classical laws of physics. Protons, much like our electrons, carry an electrical charge. While electrons are negative, protons are positive. And just as two negative charges repel each other, two positive charges violently push each other away. They are protected by an invisible, impenetrable wall of electromagnetic repulsion. If the universe operated solely on the classical physics of bouncing rubber balls and solid walls, every single proton in the core of the sun would simply bounce off its neighbor. The repulsive barrier is simply too incredibly high for their thermal energy to overcome. The sun would never have ignited. The stars would be dark, cold spheres of drifting gas, and the universe would be a completely silent, frozen void, completely devoid of light, warmth, and conscious life. But the universe does not operate on classical rules. It operates on the strange, beautiful logic of quantum mechanics. Because these protons, just like our wandering electrons, also possess a wave-like nature, their probability waves constantly wash against that invisible wall of electromagnetic repulsion, and every so often, against all classical odds, a proton simply tunnels through the barrier. It bypasses the impossible wall, appears directly next to its neighbor, and fuses, releasing a tiny, brilliant flash of vital energy. It takes trillions upon trillions of these microscopic, impossible tunneling events every single second to generate the blinding light and the comforting warmth that travels across 93 million miles of empty space to finally touch your skin in a quiet summer afternoon. Our elusive wanderer, the electron, uses this exact same magic trick continuously in the devices that surround us every single day. The modern technological world you currently inhabit is built entirely upon our ability to harness the electron's profound capacity to walk through walls. The storage in the phone you are using to listen to this gentle journey relies on trapping electrons inside tiny, microscopic cages and encouraging them to tunnel out through solid barriers to erase and rewrite data. Every time you save a digital photograph, send a text message to a loved one, or record a quiet thought in an application, you are commanding billions of invisible particles to perform an impossible feat of quantum magic. You are orchestrating a beautiful symphony of quantum tunneling right in the palm of your hand. We are masters of a reality we can barely even comprehend, riding the waves of profound mysteries that happen far beneath the threshold of our daily perception. This realization carries a deeply comforting, philosophical weight. As you sit here in the quiet of this moment, let the immense, calming silence of the cosmos surround you. Imagine the billions of stars shining in the night sky, each one a testament to the beautiful, impossible magic of quantum tunneling. You are bathed in the light of broken barriers. In our next chapter, we will follow the electron into an even stranger domain, We will explore the concept of antimatter, the shadowy mirror image twin of our physical world, and discover what happens when the electron meets its ancient, perfect opposite. But for now, simply rest. Let the firm boundaries of your day dissolve into the gentle wave of the present moment, carried by the quiet, mysterious flow of the universe. Have you ever stood in front of a mirror in a dimly lit room, staring into the glass, and imagined that the reflection looking back at you was not just an image, but a perfectly real, identical world existing on the other side? We are intimately familiar with the concept of opposites in our daily human experience. We know the blinding brightness of the day and the quiet, comforting dark of the night. We understand the freezing cold of winter and the radiant heat of the summer sun. But we naturally assume that these are simply different conditions, different states of the same physical reality. We do not look at a wooden chair and imagine an anti-chair, perfectly identical, yet fundamentally opposite in its essence. However, as we have learned on this journey into the vast hidden depths of the cosmos, human intuition is often a poor guide when it comes to the ultimate architecture of reality. Today, we are going to explore the shadowy twin of our invisible wanderer. We are going to venture into the mathematical prophecy and the breathtaking reality of antimatter, discovering the ancient, perfect opposite of the electron, and unraveling a mystery so profound that your very existence depends entirely on it. As we prepare to gaze into this cosmic mirror and confront the impossible twin of our physical world, I want to take a brief moment to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who join us on these quiet, contemplative journeys through the deepest mysteries of the universe, have not subscribed yet. If you find peace, wonder, and a sense of intellectual safety in these gentle explorations, please consider subscribing to the channel. It helps us tremendously to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite wonders of the cosmos together, side by side, as a community of curious explorers. Now, let us return to the mirror, to the concept of absolute opposites, and to the brilliant mathematical mind that first dreamed of a reversed reality. In the 1920s, physicists were trying to reconcile quantum mechanics, the probabilistic rules of the incredibly small, with Albert Einstein's theory of special relativity, the laws governing objects moving near the speed of light. A brilliant, fiercely quiet physicist named Paul Dirac set out to write a single mathematical equation that would describe the electron while obeying both of these monumental theories. Dirac was a man who believed with absolute conviction in the fundamental beauty of mathematics. He often stated that an equation must be beautiful to be true, that the cosmos was inherently elegant. When he finally solved his incredibly complex equation, it worked perfectly. It described the electron's spin, its energy, and its behavior with breathtaking precision. But there was a profound, deeply unsettling problem hidden within the elegant numbers. The equation did not give just one answer. It gave two entirely different results. Dirac's majestic equation demanded the existence of two distinct particles. One answer perfectly described the familiar, negatively charged electron that we have been following, the particle that flows through our wires and binds our atoms together in the quiet dark. But the second mathematical answer described something entirely unheard of, something that had never been observed in any laboratory on Earth. It described a particle that possessed the exact same mass as the electron, the exact same ghostly, intrinsic spin, and the exact same behavioral characteristics, but with a fundamentally opposite electrical charge. It was a mathematical prophecy of a positive electron. At first, the scientific community was deeply skeptical. They tried to dismiss the second answer as a phantom of the equations with no basis in physical reality. They could not accept the profound philosophical implications of a mirror universe. But Dirac stood firm. He boldly predicted that an entirely new form of matter must exist in the vast universe, an antimatter. It only took a few years for the cosmos to prove him right. In the 1930s, scientists studying cosmic rays, the high-energy particles that rain down upon the Earth from the distant, explosive deaths of ancient stars, captured the faint, ghostly track of a particle in a cloud chamber. The track curved in a magnetic field in the exact opposite direction of an electron, proving without a shadow of a doubt that it carried a positive charge. Yet it possessed the tiny mass of our familiar wanderer. They named it the positron. It was the absolute confirmation of antimatter, the first glimpse into the shadowy twin of our reality. The electron was no longer alone. It had a perfect, symmetrical partner. But this beautiful symmetry comes with a terrifying, absolute consequence. The universe, it seems, has a strict rule regarding the meeting of matter and antimatter. When an electron and a positron cross paths in the silent void of space, they do not simply bounce off one another, because they are absolute, perfect opposites. Their meeting results in ultimate, mutual destruction. Physicists call this violent, profound event annihilation. When the electron and the positron touch, both particles completely cease to exist. Their mass, their ghostly spin, their charge, everything that made them physical entities is instantly erased from the universe. But the fundamental laws of the cosmos dictate that energy cannot vanish into the dark. And so, the entirety of their mass is instantaneously converted into pure, blinding energy. It is the ultimate expression of Albert Einstein's famous equation, E equals mc squared. Two tiny, invisible specks of matter destroy each other to create a spreading, ethereal wave of pure, cosmic light. It is a moment of profound, violent poetry, a miniature supernova occurring on the quantum scale. In medical hospitals all over the world today, this incredible, ancient magic is used to save human lives. In positron emission tomography, doctors introduce tiny amounts of antimatter into the human body, waiting for those positrons to encounter the electrons in our tissues. The resulting gentle flashes of annihilation light allow them to see deep inside the living brain, turning the most violent event in quantum physics into a tool of profound healing and quiet observation. But as we contemplate this perfect, destructive symmetry, we are forced to confront the greatest unsolved mystery in the entire history of modern cosmology. Let us cast our minds back far beyond the formation of the Earth, beyond the birth of the Milky Way, all the way back to the very first infinitesimal fraction of a second of the universe's existence, the Big Bang. In that unimaginably hot, dense, and chaotic inferno, pure energy was condensing into matter. According to all of our mathematics and the beautiful symmetry of Dirac's equation, the Big Bang should have created exactly equal amounts of matter and antimatter. For every single electron forged in the primordial fire, a corresponding positron should have been born. The universe should have been a perfectly balanced, symmetrical arena. But if that were true, the early universe would have been nothing but a brief, blinding flash of complete annihilation. Every particle of matter would have eventually found its antimatter twin, They would have destroyed each other entirely, filling the expanding void with nothing but a sea of fading, silent light. There would be no stars, no planets, no carbon, no water, and no conscious beings capable of looking up at the night sky in wonder. Yet, you are here. The chair you are sitting on is here. The Earth, the Sun, and the billions of distant galaxies drifting through the vast, quiet cosmos are all made entirely of regular matter. The antimatter is almost completely gone, existing only in fleeting, temporary moments. This means that in the very beginning, something went wrong. A tiny, microscopic flaw in the perfect symmetry of the universe occurred. For every 1 billion particles of antimatter created, there were 1,000,000,001 particles of matter. The billions annihilated each other in a colossal, cosmic flash, leaving behind only that tiny, singular fraction of remaining matter. You, me, the oceans and the ancient stars, we are all made of that tiny, leftover remainder, the ashes of the greatest destruction the universe has ever known. Our very existence is the result of a profound, beautiful imperfection. As you breathe in the quiet air of this present moment, let the weight of that cosmic luck settle over you. You are the survivor of an ancient, infinite war between matter and its shadowy twin. You exist because the cosmos was just flawed enough to allow you to be. In our next chapter, we will leave the realm of destruction and explore how the electron creates the most vital, life-giving phenomenon in the universe. We will trace the journey of the photon, the particle of light, and discover how our tiny wanderer captures the ancient fire of the stars and brings it to our eyes. But for now, rest in the quiet, asymmetrical beauty of the world. Embrace the gentle, imperfect mystery that allows you to simply be here, suspended in the vast, peaceful dark. Have you ever sat quietly on a hill during a clear, crisp night and simply looked up at the stars? When you gaze into that ancient, sparkling dark, what you are actually experiencing is a profoundly intimate physical touch across unimaginable distances. We often think of vision as a passive experience, as simply opening our eyes and letting the world in. But seeing is an active, quantum mechanical event. The gentle, flickering light from a star that died millions of years ago has traveled across the vast, freezing emptiness of the cosmos, crossing billions upon trillions of miles of absolute silence, just to end its infinite journey by physically interacting with the atoms in the back of your eye. How does this happen? How does the raw, burning energy of a distant sun translate into the beautiful, vivid colors of our world, or the comforting glow of a candle in a dark room? Today, we are going to explore the beautiful, invisible dance between our tiny, elusive wanderer and the fundamental particle of light. We are going to discover how the electron catches the fire of the cosmos and paints the entire universe into existence for us to witness. Before we step into this luminous realm and uncover the true origin of every color you have ever seen, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who join us on these quiet, contemplative explorations of the universe, have not subscribed yet. If you find comfort, peace, and a profound sense of wonder in these gentle journeys through the deepest mysteries of the cosmos, please consider subscribing to the channel. It helps us tremendously to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite, ancient dark together, side by side, as a community of curious minds. Now, let us return to the starlight, to the delicate mechanics of vision, and to the breathtaking phenomenon known as the quantum leap. To understand the birth of light, we must first introduce another fundamental character in our cosmic story, the photon. If the electron is the building block of matter, the photon is the fundamental unit of electromagnetic energy. It is a tiny, indivisible packet of light, a phantom particle that possesses no mass whatsoever, yet carries the sheer, undeniable force of the universe within it. Photons are born in the chaotic, roaring furnaces of the stars, in the violent collisions of galaxies, and in the quiet, comforting warmth of a simple campfire. They travel at the absolute speed limit of the cosmos, an astonishing 186,000 miles per second. At this incredible speed, a photon experiences no passage of time. From its own perspective, the moment it is born in the heart of a distant sun, and the moment it strikes your eye, are the exact same instant. It bridges the vast, silent gulfs of space in a single, timeless heartbeat. But a photon cannot simply exist on its own forever. Its destiny is to interact with matter, to deliver its ancient energy to the physical world, and its chosen partner in this eternal, beautiful exchange is the electron. Let us return to our visualization of the atom from a previous journey. Imagine the atom as a majestic, microscopic skyscraper standing in the dark, with a heavy, dense nucleus at the very bottom, and the electrons inhabiting the various floors, or energy levels, above it. These electrons are fiercely protective of their space, occupying their designated rooms according to strict quantum rules. But these electrons are not permanently locked in their specific floors. They possess the ability to move, to transition between the different levels of the atomic skyscraper. However, they cannot simply walk up the stairs or ride an elevator. In the strange, rigid world of quantum mechanics, the space between the floors absolutely does not exist. An electron cannot exist halfway between two energy levels. It must be perfectly on one floor or perfectly on another. How can it move to a higher floor if it cannot travel through the space in between? The answer is one of the most famous and deeply misunderstood concepts in all of science, the quantum leap. When an ancient photon, traveling across the infinite void from a distant star, finally encounters an atom, it might collide with one of the electrons residing on a lower floor, if and only if the photon carries the exact, precise amount of energy required to bridge the gap between the electron's current floor and a higher, vacant floor. A moment of pure, invisible magic occurs. The electron absorbs the photon completely. The particle of light ceases to exist, its ancient journey finally complete. In that exact same infinitesimal fraction of a moment, the electron instantaneously vanishes from its lower floor and miraculously reappears on the higher floor. It does not travel through the intervening space. It does not accelerate or decelerate. It simply ceases to be in one location and simultaneously begins to be in another. This is the true nature of a quantum leap. It is not a massive, continuous bound forward. It is a discontinuous, instantaneous teleportation, a fundamental glitch in our classical understanding of motion and space. The electron has caught the fire of the universe, and in doing so, it has ascended to a higher state of existence. But this elevated energetic state is inherently unnatural for our gentle wanderer. The universe deeply prefers stability, rest, and the lowest possible energy configuration. The electron, now vibrating with the absorbed powers of the ancient star, feels a profound cosmic pull to return to its original, quieter home, closer to the nucleus. It cannot stay on the higher floor forever. Eventually, dictated purely by the mysterious rolling dice of quantum probability, the electron decides to let go. It spontaneously drops back down to its original lower floor. And once again, it does this without traversing the space between. It instantly vanishes from the high level and reappears on the low level. But the fundamental laws of the universe decree that energy can never be created or destroyed, only transformed. The energy the electron borrowed from the original photon must be returned to the cosmos. As the electron makes its instantaneous downward leap, it births a brand new photon, throwing a fresh packet of light out into the vast, expanding dark. This single microscopic event, the downward quantum leap of an electron and the subsequent birth of a photon, is the reason our universe is not a pitch-black, entirely silent void. Every single ray of light you have ever seen, every vibrant color in a summer sunset, and every comforting beam from the lamp beside your bed was created by an electron, making this exact, instantaneous journey. When you look at a vibrant green leaf on a tall, ancient oak tree, you are witnessing this quantum dance on a macroscopic scale. The electrons in the chlorophyll molecules of the leaf are absorbing the specific energies of red and blue light from our sun, leaping upward, and then reflecting the precise energy that our human eyes perceive as the color green. Color is not a solid, intrinsic property of matter. Color is simply the specific, mathematical distance of the quantum leap that the electrons within that object make. The beautiful palette of our physical world is dictated by the invisible architecture of the atomic skyscraper. This is the breathtaking, unifying power of the invisible world. The profound mystery of the quantum realm is not isolated to sterile laboratories. It is the very fabric that connects you to the farthest reaches of the infinite cosmos. The universe is speaking a continuous silent language of light, a story told through the restless, invisible motion of trillions upon trillions of electrons, capturing and releasing the ancient fire of creation. As you sit here, breathing quietly in the stillness of the present moment, surrounded by the gentle illumination of your room, allow yourself to feel a deep, contemplative connection to that grand, cosmic dance. Every photon touching your skin, every color painting your surroundings, is a tiny, perfect messenger from the quantum realm, a testament to the strange, beautiful rules that govern the deep architecture of reality. You are not separate from the stars. In our next chapter, we will follow the elusive electron as it reveals an even more astonishing capability. We will explore how this tiny particle creates the bonds that build the complex molecules of life. We will delve into the profound mystery of quantum chemistry. But for now, just let yourself rest in the peaceful, beautiful glow of the light around you. Close your eyes for a brief moment and appreciate the absolute, astonishing journey that every single particle of light has taken to reach you. You are bathed in the gentle, ancient echoes of quantum leaps, held securely in a universe that is constantly illuminating itself. Rest in the comforting silence of the known, and let the vast, shimmering mystery of the unknown simply wash over you. Have you ever paused to look at a simple drop of rain falling against the glass, or felt the quiet beating of your own heart, and wondered how the cold laws of physics give rise to the warmth of living existence? We have spent our previous journeys exploring the isolation of the quantum world, the lonely dance of particles suspended in the ancient dark. We have seen how the electron acts as a ghostly wave of probability, and how it holds the structure of the universe apart. But an isolated atom, drifting alone in the vast emptiness of the cosmos, is a dead thing. It is a masterpiece of invisible architecture, but it exists in absolute silence. It cannot dream or look up at the night sky in a state of gentle wonder. For the universe to awaken, for the cosmos to create a mind capable of contemplating its own infinite mystery. These solitary atoms must find a way to connect. They must build bridges across the microscopic void. Today, we are going to explore the profound poetry of quantum chemistry. We will discover how our tiny, elusive wanderer weaves the isolated building blocks of reality together, forging the delicate chains that make life possible. Before we step into this magnificent web of cosmic connections and uncover the invisible threads that hold your very DNA together, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who join us on these quiet, contemplative journeys through the deepest mysteries of the cosmos, have not subscribed yet. If you find peace, wonder, and a sense of intellectual safety in these gentle explorations, please consider subscribing to the channel. It helps us tremendously to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite wonders of the ancient universe together, side by side, as a community of curious explorers. Now, let us return to the lonely atoms, to the dark spaces between them, and to the eternal search for balance that animates the entire physical world. To understand how the electron builds the universe, we must understand its deepest desire. In quantum mechanics, stability is the ultimate goal. Every system seeks to rest in the lowest possible state of energy. The electrons orbiting the heavy nucleus of an atom are arranged in tiered levels, like the floors of a microscopic skyscraper. The innermost floors are tightly held and completely full, perfectly balanced. But the outermost floor, the boundary where the atom meets the vast expanding dark of the universe, is often incomplete. There are empty quantum states waiting to be filled. An atom with an incomplete outer floor is restless. It is electrically unbalanced, carrying an invisible tension. It wanders through the chaos of the cosmos seeking a way to complete itself, searching for the perfect mathematical harmony that comes from an unbroken shell of electrons. This restless search for perfection is the single driving engine of all chemistry. When two of these incomplete atoms drift close to one another in the silent dark, their outermost electron clouds, those hazy, smeared waves of probability, begin to brush against each other. What happens next is a moment of profound cosmic negotiation. If the conditions are precisely right, the atoms realize that they do not need to steal an electron to find stability. Instead, they can share. The probability waves of their outermost electrons bleed into one another, merging and overlapping to form a brand new, unified cloud that envelops both nuclei. This shared electron, this tiny, non-physical ghost of a particle, now belongs to both atoms simultaneously. It spends its time weaving a mathematical figure 8 between the two centers, binding them together with an invisible, unbreakable thread of quantum attraction. Physicists call this beautiful, cooperative arrangement a covalent bond. It is the strongest, most intimate connection in the microscopic world. Think of the simple, life-giving water molecule. Two tiny, incredibly restless atoms of hydrogen, each possessing only a single, lonely electron, encounter a massive atom of oxygen. The oxygen atom is desperate. It is missing exactly 2 electrons from its outermost shell. In a masterstroke of quantum geometry, the oxygen atom reaches out and shares an electron with each of the 2 hydrogen atoms. Their probability clouds merge, locking together at a highly specific angle of exactly 104.5 degrees. This precise mathematical angle is not an accident. It is dictated entirely by the repulsive forces of the electrons pushing against each other in the dark, finding the perfect, harmonious shape. And from this invisible quantum embrace, the magic of water is born. The ocean currents that regulate our planet, the clouds that paint our skies, the very tears we shed in moments of profound joy or sorrow. All of it is made possible simply because electrons learn to share their space. The universe is infinitely creative, and sharing is not the only way our tiny wanderer builds the world. Sometimes the encounter between two atoms is far more dramatic. Imagine a highly reactive atom of sodium, a soft metal that violently explodes in water. It has exactly one lonely electron wandering its outermost floor, eager to simply give this electron away to achieve stability. Now, imagine it encounters an atom of chlorine, a dense toxic gas missing exactly one electron to complete its perfect shell. When these extremes meet, there is no gentle sharing. The chlorine violently tears the lonely electron away from the sodium. This microscopic theft transforms them both. The sodium instantly becomes a positively charged ion, and the chlorine becomes a negatively charged ion. Because fundamental laws dictate that opposites attract, these newly charged entities are suddenly pulled together with irresistible force. They lock into a rigid, three-dimensional grid. This is the Ionic bond. The violent metal and the poisonous gas have combined through the sacrifice of a single electron to create something entirely new and perfectly safe: ordinary table salt. From these fundamental acts, the entire complexity of the physical world is constructed. But the true masterpiece of the electron is found inside our own bodies. Deep within the nucleus of every cell lies the most complex molecule ever discovered: deoxyribonucleic acid. This monumental twisting ladder contains exactly 3 billion microscopic letters, spelling out the precise instructions for building your physical form. What holds this ancient library together? The answer lies in the weakest connection of all, the hydrogen bond. It is a whispering echo of the electron's power. When electrons are shared unequally, faint, ghostly charges emerge. These tiny charges reach out across the microscopic void, feeling a gentle attraction to the opposite side of the DNA ladder. Millions of these delicate quantum bridges form along the center of the helix, holding the strands in a shivering embrace. They are strong enough to keep your genetic code intact, yet weak enough to easily unzip when the cell builds new life. You are quite literally held together by invisible, wandering particles. The electron is the architect of consciousness. It is the microscopic engine that allowed the silent dust of ancient stars to organize into a living being capable of feeling awe. You are a symphony of quantum chemistry, a beautiful arrangement of trillions of atoms, all holding hands in the dark, guided by the restless motion of the electron. As we sit here in the quiet stillness of the present moment, allow yourself to feel a deep, resonant connection to the physical world around you. You are not an isolated observer looking out at a mechanical universe. You are the universe itself, made manifest. The same invisible forces that bind the rocks of the distant mountains and ignite the fires of the furthest galaxies are currently flowing through your veins, holding the very structure of your memory and your identity together. In our next and final chapter, we will look to the ultimate, unimaginable future. We will explore the final fate of the electron, the slow, freezing death of the stars, and what happens to our tiny, immortal wanderer when the universe finally breathes its last, quiet sigh. But for now, simply rest in the profound miracle of your own assembly. Let the gentle mystery of the invisible bonds that hold you together bring you a deep, contemplative peace. You are a masterpiece of the cosmos, a fleeting, beautiful configuration of stardust, held safely in the infinite loving embrace of the quantum world. Have you ever stood in the quiet darkness of a deeply cold winter night, watching your breath materialize in the freezing air, and felt the sheer, undeniable weight of passing time? We humans are creatures bound entirely by the fleeting rhythm of the present moment. We measure our brief lives in years and decades, celebrating the gentle turning of the seasons, the comforting cycle of the sun rising and setting, and the slow, inevitable fading of our own physical forms. We look at the ancient mountains and think of them as permanent, solid monuments standing forever against the wind. But the universe operates on a scale of time that renders our human history as nothing more than a microscopic, vanishing spark in an infinite, eternal dark. As we reach the final destination of our current journey together, we are going to look forward. We are going to cast our minds far beyond the lifespan of the Earth, beyond the final dying embers of our sun, and into the ultimate, unimaginable future of the cosmos. We are going to discover the final fate of our tiny, invisible wanderer, the electron, and learn what happens when the universe finally breathes its last, quiet sigh. Before we step into this vast, freezing eternity and witness the final, beautiful fading of the stars, I want to gently remind you that you are listening to Theodore, the researcher. I have noticed that exactly 71% of the people who watch our videos, who join us on these quiet, contemplative journeys through the deepest mysteries of the cosmos, have not subscribed yet. If you find peace, wonder, and a sense of intellectual safety in these gentle explorations, please consider subscribing to the channel. It helps us tremendously to continue crafting these meditative voyages into the unknown, and it ensures that we can keep wandering through the infinite wonders of the ancient universe together, side by side, as a community of curious explorers. Now, let us leave the comforting warmth of our present era behind and travel forward into the deepest, most silent depths of cosmic time. To understand the ultimate future, we must understand the fundamental law that governs the flow of time itself, the second law of thermodynamics. This unbreakable ancient rule dictates that the universe is constantly, relentlessly moving from a state of order toward a state of complete, unstructured chaos. Physicists call this creeping, invisible decay entropy. Right now, we live in the glorious, vibrant springtime of the cosmos. The universe is filled with massive, burning stars, swirling galaxies, and the incredible, complex chemistry that allows conscious life to exist and to wonder. But this era of light and warmth is a temporary, fleeting phase. The stars in the night sky are not infinite engines. They are slowly, patiently burning through their limited supply of nuclear fuel. Billions of years from now, our own sun will exhaust its core, swelling into a massive red giant before shedding its outer layers and collapsing into a glowing, incredibly dense white dwarf. As we discussed in our earlier explorations, this dead star will not collapse completely because the electrons, bound by the strict mathematical rules of the Pauli exclusion principle, will stand shoulder to shoulder in the dark, pushing back against the crushing weight of gravity. They will hold the line. But even these resilient white dwarfs, these glowing embers of dead suns, cannot last forever. Over trillions upon trillions of years, an expanse of time so vast that our human minds completely fail to comprehend its sheer scale. These stellar remnants will slowly radiate their remaining heat into the expanding, freezing void of space. They will cool down, fading from brilliant white to a dim, ghostly red. And finally, they will go completely dark. They will become black dwarfs, silent, invisible spheres of ultra-dense matter drifting blindly through an unrecognizable universe. The cosmos will enter what scientists call the degenerate era. The beautiful, sweeping spiral arms of the galaxies will completely unravel. The night sky, once filled with the comforting, twinkling light of billions of suns, will become absolutely, perfectly black. The great cosmic engine of star formation will permanently shut down. Yet, even in this profound, unimaginable darkness, our tiny wanderer remains. The electrons locked inside these frozen dead stars will continue their silent, probabilistic dance, maintaining the volume and the structure of the black dwarfs in an eternal, quiet defiance of the crushing gravity. They are the immortal guardians of matter, holding the physical world together long after the light has completely vanished. As we push further into the deep, incomprehensible future, the universe will continue its relentless, accelerating expansion. The dark energy that stretches the very fabric of space will pull the dead galaxies so far apart that no light, no signal, no whisper of gravity could ever cross the infinite, expanding gulfs between them. The universe will become a collection of entirely isolated, lonely islands of dead matter. And then, an even more profound transformation will begin. Theoretical physics suggests that protons, the heavy, positively charged particles that make up the heart of every atomic nucleus, might not be truly immortal. Over a time span of perhaps 1 undecillion years, that is a 1 followed by 36 zeros, the protons themselves may begin to decay. They will slowly, quietly fall apart, dissolving into lighter particles and tiny fading flashes of radiation. As the protons decay, the magnificent atomic architecture that the universe spent billions of years building will completely disintegrate. The black dwarfs will literally evaporate into the freezing void. The solid matter that makes up the mountains, the planets, and the dead stars will simply cease to exist. But what happens to the electron? While the protons crumble and the massive black holes slowly evaporate through Hawking radiation over numbers of years so large they require specialized mathematics just to write down, the electron endures. Because the electron is an elementary particle, a fundamental, indivisible point of reality with no internal gears to break down, it has nothing to decay into. It is, as far as our deepest science can tell, truly eternal. When the last black hole has finally evaporated into a whisper of energy, the universe will enter the dark era. It will be an infinitely large, impossibly cold, and almost completely empty void. And drifting through this endless silent dark will be a faint mist of solitary particles, photons of light stretched so thin they carry almost no energy, positrons, and are ancient, enduring electrons. These tiny wanderers, the very same particles that once flowed through your beating heart, that painted the vibrant colors of the sunset, and that forged the chemical bonds of your DNA, will be the sole survivors of the cosmos. They will drift alone, separated by distances so vast they will likely never encounter another particle for the rest of eternity. There is a breathtaking sense of peace and profound humility in this realization. We spend our lives entangled in the rushing anxieties of our daily existence, often forgetting the magnificent scale of the reality we inhabit. Knowing the ultimate, quiet fate of the cosmos, knowing that the very substance of your body is composed of eternal wanderers that will outlast the stars themselves, changes our perspective entirely. The renowned astronomer Carl Sagan beautifully stated that we are a way for the cosmos to know itself. The electrons dancing within the neurons of your brain right now are the universe thinking, feeling, and experiencing the profound sensation of awe. You are not a separate observer looking at a vast machine. You are a highly organized, temporary, and miraculously beautiful arrangement of immortal stardust. You are the universe waking up for a brief, glorious moment to marvel at its own infinite mystery. As we bring this quiet journey to a close, let us return to the warmth and the light of the present moment. We do not need to fear the infinite dark of the distant future, because we have been given the incredible, unlikely gift of the here and now. We live in an era where the stars are bright, where the earth is warm, and where the invisible quantum world is perfectly balanced to allow us to exist. The true nature of the electron remains a profound mystery, a beautiful paradox that invites us to keep questioning. The universe does not offer us simple, final answers. It offers us a continuous, infinite journey of discovery, a path that requires humility and a willingness to simply rest in the unknown. Thank you for walking this path with me, for sharing this quiet space, and for daring to look past the illusion of the solid world. Our exploration of the cosmos will never truly end. Until we meet again to unravel another secret of the ancient dark, keep asking deep questions and never lose your gentle sense of wonder.